Oh, well, I guess there's half of it not recorded, but so the sort of approach to take here is to use design elements that are in tension with each other. So rather than saying, this is the strategy I want to enable, and I need these things around here to enable it, I say I want two things that resolving the balance between those two things is really non-trivial. It's a paradox. They want things that are incompatible with each other, but somehow the system and the players in the system have to come to some solution to how to make that compromise. You create that paradox, but then you make it the player's problem. And that way you can leave open some space for you to learn something new. So I'm going to talk about three motifs, and these are not meant to be exhaustive. And similarly, just having, one of these is not like, oh yeah, definitely emergence, but these are things which I think there's a reason to think that this is going to give you that kind of tension that you need, or it's going to give you that kind of internal conflict that you need. And if you, tune that the right way, then you might get lucky and find something interesting pop out of the system. And those motifs are the use of sort of incompatible scaling laws, the use of things with spatially and temporally extended influence, and then also resolving atomic actions in the game, in this case, into an extended body, so that something that the player might do with a single button press actually sets into action all sorts of processes within the world that actually determine what really happens. So starting with the incompatible scaling laws, the idea here is that different physical mechanisms create relationships between space and time and material. They create constraints that need to be satisfied in different ways that scale with the system size. And the idea here is that if you start understanding the game at sort of a small level, but then players keep playing the game, they keep building up, make it so that somehow when you build up in whatever direction up is, longer time, greater length, bigger empires, whatever in your space game, the game should change on its own. Like the things that need to be considered should change on their own. And so an example of this is the sort of well-known relationship where muscle strength scales as the cross-sectional area. So the square of the length scale of an organism, but body mass scales as the volume. And so if you have a certain body architecture, a certain kind of muscle tissue, et cetera, there's a maximum size before it can't support its own body weight. And so if you had some reason, some push to keep getting bigger and bigger and bigger, if you wanted to extend there, then as you hit those scales, you have to change the architecture of the body. You have to change what the muscles are made of. You have to change some kind of assumption and discover something new, or you can't go there. Another example is the nucleation of a droplet or like a bubble of steam in boiling water, where when you have a very tiny bubble that just forms, there's the surface tension that essentially wants that bubble to shrink and go away. But if the water is above the boiling point, or just slightly above the boiling point, ready to go, then there's an extra bulk energy that can be released by converting from the water to steam, and that goes as the volume that you manage to convert. So if you start with a bubble that's too small, it will shrink. If you start with a bubble that's bigger than that, it will grow. And so again, there's this kind of special scale that is created by the tension between these two scaling laws, at which the nature of the dynamics changes. So in games, you can see these things a lot coming from logistics problems, where you have something that needs to be transported, and it doesn't just pop. It's not just going into a big buffer of how much money or how much energy you have, but it actually has to go from where it's produced to where it's consumed, or otherwise things have to actually connect to each other through the actual space of the world of the game. This is a city from City Skylines that I built. And as you build the city larger and larger, if you're just using local roads, traffic will eventually just choke everything. So you start to have to make more and more complicated transportation networks using things like rail, using things like bus systems to feeder stations. You have to change the layout from just being grids to hierarchies, organize the city in different ways. As you try to make a bigger and bigger city, the nature of the game you're playing kind of changes fundamentally, and new strategies become necessary basically to get there. Similarly, in a game like Factorio, you have a lot of intermediate products that have to be moved around from where they're produced to where they're consumed. And building a small factory is quite easy. You can just be very sloppy or do spaghetti conveyor belts. But if you want to actually scale that up to a large factor, you have to start to take into account that the transport belts will actually take up a significant portion of the space of the factory floor. And so people come up with organizations like having a sort of main bus that things can be peeled off of and put back on, or they'll separate the production into these kind of self-consistent modules who only talk to each other through much more condensed products. So the reason why these logistics things give rise to it is that if I have something that's traveling through space of some dimension d, so in 2D it's 2, then the kind of bandwidth I have is only going to scale as L to the d minus 1, because it basically has to go from one end of the system to the other. And the only thing I can do to make more stuff be able to go is increase the width of that road. I can't, increasing the length of the road doesn't let me transport more stuff. But if I'm filling everything else up with, sources and sinks, then the amount that I have to transport scales as the dimension, and those are incompatible. So as I ask, the thing that is producing and consuming to grow, eventually I will have a system that's entirely made of roads unless I somehow fundamentally change the organization of the system. Maybe I use some kind of fractal organization of how things are produced and consumed. Maybe I make little clusters that are self-consistent. But it forces that kind of change. And this is sort of a generic thing with transporting things through space. So the second motif is to have things with spatiotemporal extent. And I don't necessarily just mean a physical body of the thing, but also the consequences of that body. So this is the incredible machine, and an action at the top of the screen with that bowling ball can basically propagate a consequence down to the bottom of the screen where the balloon pops. That allows the set of interacting things in the system to be much larger than just kind of a local cluster. And that means that as the system grows, the potential side effects and consequences and so on also grow in a way that allows for the emergence of new indirect strategies for manipulating and controlling the dynamics and playing that game. It becomes possible to think that rather than directly trying to achieve your goal, you can interfere with something that is transmitting one of these consequences. This shows up in games like Go and chess, in the sense that a single stone in Go can have a non-local influence due to structures like those ladders. If you have a what's called a ladder breaker, it can completely change what is worth doing at the other end of the board. And that move, even though it's very far away from the actual ladder structure, kind of interacts with its implied body, the moves that could happen. Similarly, a piece in chess is not just the size of the single piece in the single square, it's also all of the areas it protects or all of the areas it threatens. And the final motif that I want to talk about is about resolving atomic actions. And here again, what I mean by an atomic action is something that the player or the agent, who's interacting with the game is doing with a single button press effectively. So moving to the left or shooting or replicating if it's a life simulation sometimes, or casting a spell. And if those are implemented in a way that's kind of closed and modular, that limits the degree to which those things can actually become greater than they are. But if instead you actually take that process and you implement it, not in a way that the player necessarily has to directly do themselves, but just in the world. So, hitting that button starts a whole process of things going on inside of the agent or even inside of the agent's environment that culminate in the expected behavior in most cases. Then that opens up the possibility for there to be these extra ways, to play. And an example here is this game called Besiege. And there's a whole family of these games where you kind of build them ups, where you build a body for yourself and then you do things with that body. You build a spacecraft in Kerbal Space Program or a car in Terra Tech. But in Besiege, you're building these sort of medieval tanks, and you can wire them up to your arrow keys. So yes, you can just go forward, go back, or shoot. But that's all happening in the physics of the elements that make up that body. And as a result, there are consequences. If the ground changes, if it's snow or sand, if there's a boulder, then the body doesn't work quite the same way as in the sort of, base case. Similarly, by changing the environment, you can change how that agent is going to be able to go. You can clear away snow or make a road. In Besiege in particular, every piece of that body has a certain tolerance to stress. And if you push it too far, stuff will start to break. And the dynamics of the body itself will also begin to change. So one thing that I've seen in ALIFE, but I don't know if I have a good video game example of this, is that when you start to do this and resolve atomic actions, you can have multiple agents become kind of entangled into effective, larger complexes that themselves play a game with different rules. And the example in ALIFE that comes to mind is Tierra, where you have this sort of replicating programs in a linear sort of assembly-like memory, where there are a bunch of CPU cores that essentially run these programs and thereby make copies. So the CPU cores are sort of a resource that's limited. And what will happen is you'll get the emergence of parasites that essentially borrow the CPU core from another string in order to replicate themselves so that they don't need their own CPU. So they create a kind of extended organism because that replication, that CPU, running on memory is the actual underlying truth and not the body of the organism. The strings are not actually a hard boundary that separates the agent from the world. So in conclusion, if you want to be surprised, design lightly and create fertile conditions for emergence to occur without targeting specific strategies. Place game elements in tension and try to extend and resolve things to increase the available interactions. So thank you.